So hi guys, how are you doing? I hope you are doing well. So let's continue with the chapter of logarithms and let's take a deep dive at the power rule of logarithms. So let's assume a scenario where you have log with the base of c and the argument of a raised to the power of b, right? Raised to the power of b. So how do you solve these types of questions where you deal with the powers on the whole terms? So our whole term is a, right? Our only term is a and our whole term is a. So we can say that a with the power of b in the scenario where b is the power of the whole term. Okay, please take a deep dive at my words. Please concentrate on my words, the words I'm trying to use. B is the power of the whole term. I do not mean by whole term as like ignoring half or ignoring 3 by 2 or ignoring mixed numbers. I do not mean that. By whole terms, I mean the whole argument, right? So our whole argument in this case is a. So b is the power of the whole argument. And if that's the case, we can say that b could be shifted backwards and it could become b log base of c and argument of a. So b can become the coefficient of the entire logarithm. So let's take another look and let's understand it better. Log with the base of d, or the base of the grade you will get if you do not lock in right now, argument of 9 with the power of 2. So our 2 is the power of the whole term, which is 9. So we can say our power can become the coefficient of the entire logarithm, or our power can be shifted backwards. So it becomes 2 log base of d argument of 9, right? That wasn't difficult, right? So ln of argument of 9x whole power 7x. Well, what will we do right now? Of course, we will follow the same pattern. So what does ln mean? Well, the base e is implied in the logarithm of ln, in the function of ln. Well, that doesn't help in this case, but the 7x is the power of the entire ln function or the entire logarithm function. So 7x can be shifted backwards because it is the power of the whole term, and our whole term in this case is 9x. It's not 9, it's not x, it's 9x. So our power of 7x can be shifted backwards and become the coefficient of the entire ln function. So we can also write it as 7x ln e argument of 9x. Wait, just let me write e in the subscript, right? Okay. Let's take another look at log base m argument of 3 raised to the power of 8x. So our entire argument is 3, right? And our power is on the whole of the argument, is on the whole of the term, which is 3, right? So in this case, again, we will follow the same rule. Our 8x will be shifted backwards and will become the coefficient of the entire logarithm function. So 8x log of base m argument of 3. Okay. Well, LG 4y plus 3 whole to the power of 9 by 2x. Well, LG means base is our 10. Our base is 10. Our argument is 4y plus 3 and our power is on the whole term, which is 9 by 2x, and our whole term is 4y plus 3. So 9 by 2x can be shifted backwards and will become the coefficient of the entire LG function. So it becomes 9 by 2x, or you can also write 4.5x, LG 10 4y plus 3. Okay. Well, do not write 10. It's not suitable. Just write LG. Okay. Now let's take a look at the function of the log multiplication function. Well, let's ignore it for a bit. Let's just ignore it for a bit. I think I should skip it. Well, I should concentrate on strengthening your concepts a little bit. Just pardon me for a slight inconvenience. So let's take a look of an example. LG 9x squared plus 5, right? LG 9x squared plus 5. Well, can we say that 2 can be shifted backwards and become the coefficient of the entire function? Well, no. No. Why? The main thing is why? Because for our power to be shifted backwards, I repeated it again and again and again and again. Our 2 or our power should be on the whole term. Our whole term is 9x squared plus 5. This is our whole term. Whole term or argument is 9x squared plus 5, right? So our power 2 is restricted to x. It's the power of x, right? It's not the power of 9x squared plus 5. So if you write it as 2lg 9x plus 5, you will only just cause harm to yourself. You will not score a point, sadly. Okay? Let's take another look, right? If it was, instead of LG 9x squared plus 5, if it was LG 9x whole square plus 5. Now, what will be the case? Well, can we say the 2 can be shifted backwards and become the coefficient of the entire function? No. Again, no. Because the power should be on the whole term. Again, our whole term is 9x squared. 9x whole square plus 5 is our whole term. The power should have been here, right? Here, right? Here. If it was here, then we could have considered and sent the 2 backwards to, so it would have been an entire different thing. Well, we'll focus on it. If that was the case, right? Let's shift it towards it. LG 9x plus 5 whole square, right? 9x plus 5 whole square. Now we can say the 2 can be shifted backwards and it will be entirely correct. Why? Because 2 is the power of the whole term, whole argument, which is 9x plus 5. So we can write it as 2lg 9x plus 5, right? Now it's correct and you will score a point, hopefully. Now let's take a look at the log multiplication. Okay, now we can take a deeper look at the log multiplication, or without any complications, because this concept is often tested. It is very much tested in the advanced paper, and I've hardly encountered a paper where this concept was not tested, or I do not know the last paper I checked where this concept wasn't tested. So, this concept was very, very important for me to discuss. Okay, so let's take a look at the log multiplication. Well, if you have a beautiful case of log of x, y, right? Now we have 2 different variables, we have 2 different numbers, we have 2 different terms. Now, what will we do? Okay, so we can write it as in the form of log x plus log y. The key term is plus. Just let me highlight it for you. Plus. Okay. Plus, because the log, the entire the variables in the variables in the functions of logarithms were being multiplied. X was being multiplied by x multiplied by y. Okay, so x was being multiplied by y, and so we can break the logarithm and we can write it as log x plus log y. Okay, let's take a look at a question. Okay, so if we have a case of log 25 x y z, okay, so we can write it as, since 25 is being multiplied by x, is being multiplied by y, and it is also being multiplied by z, the entire terms are being multiplied by each other, we can break the logarithm and we can write the plus between them. We can just simply break the logarithm. The base should remain same. In this case, it is LG, and LG has a base of, the implied base of 10. So I'm not writing 10 because in a function of LG, the base is already implied. Okay, I hope you know this. LG with the base of 10 means log 10. Oh, we just don't know, right? Well, LG means log with the base of 10. I have discussed this concept in the previous video. Make sure to check it out in the first video basically. Okay, so we can write it as log 25 plus log x plus log y plus log z, because the entire terms were being multiplied by each other. The case was 25 times x times y times z. Okay, let's take another look. Log 10x, log 5y square, and log 3ab. Well, we've been encountered with such a tedious question. Let's take a look at each of them separately. Okay, for the first case, log with the base of a and the argument of 10x. Well, because the 10 and the x are being multiplied by each other, I do not need to write it this. Okay, you guys are not in grade 6 or grade 5 that I'm forced to tell you even the tiniest bits of steps. The 10x means the 10 is being multiplied by x. I should have not discussed this. You guys are mature enough to figure out this on your own. Okay, enough talking. So we can write it as log with the base of a, 10 argument, and the plus log with the base of a, argument of x. Okay, let's take the look at another question, or the second question, or the second part. Log with the base of a, 5y square. Okay, so the square is on the whole term. Well, I didn't write it as accurate. The square is on the whole term, No, the square is only on the y term. Okay, sorry, my bad. Okay, so we can write it as log a, argument of 5, log with the base of a, argument of 5, plus log argument of y square with the base of a. Okay, because 2 is on the whole term and our whole term is y, I can shift 2 backwards, so the entire equation becomes log base a, argument 5, plus 2 log base a, argument of y. So this is our final answer. Let's take another look at the next question. Log, let me use a different color, this should do, yes. Log with the base of a, 3ab. Okay, so since 3 is being multiplied by a and b, I should have not discussed this. Okay, so we can write it as log base a, argument of 3, plus log base a, argument of a, plus log base a, argument of b. Since we know that if the base and the argument are equal in the case, well, you can see this with a different color. Yes, in this case, where you can see that, okay, the argument and the base both are same, numerically same, so it becomes 1. So the final answer becomes log base a, argument 3, plus 1, plus log base a, argument of b. let's go below, or just let's solve another question. I have a good question in my mind. What happens if we take log base b and the argument of 64z square? Let's simplify this equation into the simplest terms possible. Okay, so it becomes log base b 64 argument plus log base b argument of z square. We can also write 64 as 8 square, right? Or am I wrong? Log b and 2 becomes a coefficient of the entire logarithm operation because 2 was the power of the whole term z. Okay, our whole term was z. Okay, so 8 square and the 2 can be shifted backwards, right? Or am I wrong? Because 2 is the power of the whole term, which is 8 in this case, in this beautiful case. 2 log base b argument of 8 plus 2 log b argument of z. We can also write 8 in terms of the power of 2. Well, it becomes 2 log base b 2 power of 3 plus 2 log b argument of z. Let me use a different color, or I've just congested it a bit. Let's shift it downwards. Yeah, that should do. 3 becomes, again 3 shifts backward, shifts backwards, becomes the coefficient of the entire logarithm operation, because 3 is the power of the whole number, which is 2 in this case, okay? So it becomes 6 log base b plus 2 log b argument of z, base b argument of z. So this logarithm operation can be expressed in these simplest terms. Okay, so let's take a look at the quotient rule. What does it mean when I say quotient rule? Well, it means if I'm a lunatic and I come across a question which says log with the base of a, and we encounter a situation where two terms are being divided by each other. So instead of committing a suicide, what we do is we break the logarithm again, and instead of adding the logs, we subtract them. Simple as that. But the thing is, in this case, the order is very important because z is the numerator and should be written first. The logarithm operation in terms of z should be written first. So it will be log with the base of a, argument of z, negative. Well, if I write as positive, it's wrong, absolutely wrong. Okay, so let me write and let me highlight it, this. Okay, so this is very important. In the power rule, in the multiplication rule, you could have swapped their places and it wouldn't have even mattered. It wouldn't have even mattered. Even if I have written it as, if I wrote it as LG y plus LG x, it would have been still the same. It would have been still the same thing. 2 plus 5 or 5 plus 2 means the same. It doesn't affect your answer. It doesn't affect the logic. But in this case, if you mess up with the places, your entire logarithm operation becomes corrupt. It becomes wrong. It is wrong. Okay. So log with the base of a, argument z, negative log. I really hope you are understanding my broken English. I do not have a good English accent, so I'm just trying my best. Pardon me, brothers. Okay. So log AZ is very important and should always be written first. The numerator terms in terms of logarithm should always be written first. Let me write it, numerator in terms of log operation should always be written first. Okay? Well, let's take a look at a rather simple question, or rather warm-up question, unless we face the final boss. Yes, we are going to do some tough questions in this video. Okay, log with the base of a, argument of x upon 2. Okay, well, how will we solve this? Okay, we will apply the quotient rule, because we know that the two terms are being divided by each other and log in the terms of numerator will always be written first. So it becomes log base a argument of x negative log base a argument 2. Okay, well, that was quite easy. Let's take a look at another question. Log with the base of 2 argument of y upon 3x. Okay, so it becomes log with the base of 2 argument of y negative log with the base of 2 argument of 3x. Well, if I leave this question as here, will it be all right? Pause the video and think about it. Do not rush to the answers. Do not, just go for the answer. Just think about it a little bit and then answer, or just think, well, this ain't a live recording, live video. So just think about it a little bit. Well, no. If you leave this question as here, it is not solved. It is partially solved, but it is not fully simplified. For the entire simplification process, here's a key detail. It's log base 2 3x. Can it be simplified further? Absolutely. How? Log with the base of 2 3 plus log with the base of 2 argument of x. So yes, our multiplication rule of the logarithm will apply here as well. So the beauty of logarithm is that multiple concepts clash with each other. They not clash with, clashes are a very wrong word. They reconcile with each other, they cooperate with each other, and you get a beautiful logarithm expression which involves multiple concepts to fully solve the question, fully solve and understand the expression. So it becomes log 2y negative. Okay, so the bracket is very important. I really hope you guys know algebra, or you guys are in very serious trouble, or you guys have a bigger fish to fry instead of just rushing to the logs, and just take care of your algebra before jumping. Okay, so that becomes our final expression, and now our answer is absolutely spot on. Okay, now let's take a look at some of these questions. Well, let's start with the first question. Log, well, just assume the base is a, b, c, d and e. Okay, so log with the base of a 100 x cube y square divided by z raised to the power of 4. Now what will happen, or how will we solve this question? Okay, so it becomes, well, we will use the quotient rule. So because the two terms are being divided by each other, by the two terms I mean the numerator and denominator are not equal, so of course they are being divided by each other. When we say 2 over 5, it means 2 is being divided by 5. Okay, so what I mean is the numerator is being divided by the denominator, so we will apply the quotient rule. So it becomes log with the base of a 100 x cube y square. We write the numerator first in terms of logarithm, negative log of z raised to the power of 4. Okay, so can this question be simplified further? Yes. Okay, I hate to break it to you, but this question will be simplified further. Okay, log y square negative log z raised to the power of 4. I really hope I do not need to explain you after all that ruckus I just orchestrated. So yeah, log with the base of a argument 100 plus 3 log base to the a argument of x, because 3 is the power of the whole term x. Okay, so it could be brought backwards and it will become the coefficient of the entire operation of log, and 2 log argument 5 negative 4 log z. Okay, so that is our final answer. Let's take a look at another question. Well, this question seems terrifying. Okay, let's take a look at this question. Question number 12. Let me use a different color. Yeah, that should do. Log with the base of b argument of 5x square y upon under root a b. Okay, so again we will apply the quotient rule. I hope I do not need to explain this again. Log with the base of b argument of 5x square y negative log base of b argument of a b. Okay, log with the base of b argument of 5 plus log base of b argument of x square plus log base of b argument of y negative. Well, now I will use a bracket because I'm dealing with more than one terms, so it will become eventually the positive sign will become a negative sign. So negative log b, well, I can also write it as in the terms of, well, just screw it. Okay, let's write it as negative log b. Oh no, I have to keep the control of the bracket, so it becomes ab whole power half. Okay, log b log base b argument 5 plus log base b x square plus log base b y negative. Well, half can be brought backwards. Okay, so it becomes half log b ab. Am I wrong or am I right? Well, it turns out I am right. Okay, can it be simplified further? Yeah, because a and b are being multiplied by each other. So log base b argument 5 plus 2 log base b argument x plus log base b argument y negative. Well, it becomes half log b argument a plus half log b argument of b. Okay, further, log base b argument 5 plus 2 log base b argument x plus log base b argument y negative half log b argument a minus half times 1, because we know that if the bases and the arguments are equal, in this case the argument and the bases both are equal, both are b, so they become 1. Okay, so it becomes 1, so it's just ignored and it becomes half. So this is our final simplified expression. That wasn't easy, was it? Well, that was just a mess, nothing more, just a little headache. Let's take a look at I think the question number 14 is also based on the same pattern as that of the question number 12. Let's take a look at the question number 15, right? I think it is in a form of surds, so I think that will be a little challenging. Okay, so log, well, just let me copy it. Can I copy it? Should be. And just, yeah. Okay, let's take a look at the last question, which is log base e argument a4b square divided by c3 under root d. Okay, well, log e means ln, right? You should know this by now. So ln of a power 4 and b square negative ln of c3 under root d. Okay, yeah. So ln a power 4 plus ln b square negative ln c power 3 plus ln of under root d. Okay, well, ln a, well, I can write it as 4 ln a plus 2 ln b negative 3 ln c plus half ln d. All right, well, under root d means d raised to the power of half, and because half is on the whole argument, which is d in this case, so half can be shifted backwards, so it becomes half ln d, right? So it becomes, so final simplified expression is half 4 ln a plus 2 ln b negative 3 ln c negative half ln d. So this is our final simplified expression. So you can solve all of these questions. I think I've solved 4 questions, I guess. 3 questions among these 5 questions. Well, yeah, that's it for today. I think that's enough. We've covered a big chunk of the syllabus, I guess. Well, we will now focus on 2 main concepts remaining in the entire logarithm chapter, and then we'll be finished with this chapter for good. Well, I really enjoy teaching you guys, and please forgive my broken accent. I am not a native English speaker, but I really hope that you guys understood. I genuinely hope. I genuinely pray. Take care. Bye bye.